Let's discuss today's lead code problem. So the problem is minimum number of operations to move all the balls to each box. Okay, the problem is basically you are given n boxes. You are given a binary string boxes of length n where the boxes at index I is 0 if the ith box is empty and 1 if it contain one ball. So basically in the input it is specified key we are given a string boxes that is a binary string. It can only have 0 and 1 as its character. 0 represent empty and 1 represent one ball. Okay, okay. This thing we have understood. In one operation you can move one ball from a box to an adjacent box. Okay, let's see. 110 is the example. We need in one operation we can move one ball from a box to the adjacent box. Okay, box I is adjacent to j if absolute value of I minus j equals to 1. Okay, so it is basically key. Let's consider 110. So the it is saying ki if these two will be adjacent if the difference between the two indexes would be 1. So it is specified. Note that after doing so, there may be more than one ball in some box. Return the array answer of size n, where answer of I is the minimum number of operation needed to move all the balls to the ith box. Basically, the question is saying कि we need to find the number of operation for this particular box. कि if we considering box 0, box 1 and box 2, that is basically these ones. We need to find for each box the number of operation, the minimum number of operations to move all balls. That is all balls, or what we can say all ones, to that current box. If you haven't understood the question till yet, I'll do one dry run over it. 110 is given to us. This is the binary string. So if we consider box 0, box 1, box 2. Okay. Now, if I'm at this particular box, it already have one ball. I just need one more ball that is adjacent to it, or what we can say is the one distance ahead of it. So I just need one operation to make box 0 contain all the balls. If I am at box 1, I already have one ball. I just need one more ball that is left to it. And I need just one operation to move it from 0th index to 1. So only one operation. Okay. Now, this box 2 is quite interesting. I don't have any ball here. I need to borrow two balls that are to its left from box 1 and box 2. Box 1 is at a distance of 1. I can borrow it in one operation. Box 0 is at the distance of 2. I need two operations. First to move it to box 1, then to move it to box 2. Okay, two operations. So the total operations for box 2 are 3. And for each the boxes it is 113. That is our particular output. Okay. I do one more dry run so it would be more crystal clear to you. 0, 0, 1, 0, 1, 1. Okay, I have how many boxes? 0, 1, 2, 3, 4, 5. Box 0 to box 5. Box 1, box 2, box 3, box 4, and box 5. Good. Now, for box 0, I need 3 balls because all the balls are to its right. The ball that is at the box 2 is at the 2 distance of it. We require 2 operation. Okay. The ball that is at the box 4 is at the distance of 4. We require 4 operations. The box at the box 5 is will be requiring 5 operations to move it to box 0. So the total number of operations are 11. Good. Then I'll move to box 1. I'll check how many number of operations did it require to contain all the box. It To make the ball in the box 2 into the box 1, we require 1 operation. For box 4, we have a ball. We require 3 operations to move it to box 1. And if the ball is at 5, I require 4 operations. So total number of operations are 8. Oh, good. I am at 2. I look for its left. Any balls? No balls. I look to its right. Yeah, I have 2 balls. One is at the distance of 2 and 5 is at a distance of 3 from box 2. So the total number of operations would be 5. Good. I'm at this particular box. I look to its left. I have a ball at box 2. Okay, I require 1 operations to put it into box 3. Now for box 4, I need 1 operations to move from box 4 to box 3, and from box 5 I require 2 operations. The total number of operations would be 4. Okay, now I move to box 4. For box 4 I have 1 ball. To make the ball from box 2 to move to box 4, I require 2 operations, and similarly I require 1 operations to make the ball in the box 5 move to box 4. Okay, so 3. Again I am at 5. I already have 1 ball. I require 1 operation to move the ball from box 4 to box 5, and another operation, that is 3, to move from box 2 to box 5. Okay, it would be 4. So is it our output? Yeah, it is. So we have understood the question and we can easily come up with a naive approach. Okay, so the naive approach would be 0, 0, 1, 0, 1, 1. If I'm at a particular index, I could loop towards its left, loop towards its right, check if, because I have the index assigned to every particular box. If I'm at index 0, I will maintain a answer array 1, 2, 3, 4, 5, and 5. I am at index 0. I look for ones or balls in the left side. I don't find anyone. I look for balls in the right hand side. I I found one ball at index 2. So I'll find the absolute value, that is basically 2 minus 0. These are the minimum number of operations that are required to make the ball move from box 2 to box 0. Okay. Then I have 4. 4 minus 0. Okay. I got it. Then I have a ball at 5. 5 minus 0. It would be 2 plus 4 plus 1. 11. Good. I'm at 1. 1th index. I look for balls at the left hand side, the balls at the right hand side. Left hand side, I haven't find any ball. In the right hand side, I found a ball at index 2. Okay. The minimum number of operations required 2 minus 1. Okay. I found another ball at 4. 4 minus 1 operations. And another ball at 5. 5 minus 1. That is basically 1 plus 3 plus 4. Make it 8. Good. Then for the next index, I have 1. For the 1, I'll look for balls on the left. I haven't find anything. Look for balls on the right. I have found 1 ball at 4. The 4 minus 2 plus I have found a ball at 5. 5 minus 2, it will give me 2 and 3. Good. 5. Good, good, good. I move to the next index. I have 0 here. I look for balls on the left. I have found 1. So 2 minus 3. because it will be absolute value. So it would be 1 plus I have a ball at, sorry, yeah, I have a ball at 4. 4 minus 3. It would again be 1 plus I have a ball at 5. 5 minus 3. It would be 2. 4 would be the total value here. Good. I move to the next index. I look for balls in the left. So 4 minus 2 plus I look for balls in the right. I have found 5. At 5, 5 minus 2. 3 plus 2, 5. Okay, 4, 2, sorry, 5 minus 4 would give me 1. 2 plus 1 will give me 3. Okay, I am at index 5. So 5, I have found a ball at 2, 5 minus 2, plus I am at 5, I have found a ball at 4, 5 minus 4, 1, 3. It will again give me 4. So this approach can work if the constraint or the, what we can say, the constraint that is provided to us are less. But this will work in n into n time complexity. In the worst case, in the space complexity would be order of 1. Why I'm saying n into n? If I'm at a particular index, key I, if I'm at the middle index, I need to search for all the elements on this right, all the elements to its left, and there would be again a outer loop that would be doing the computation for each of the index. So in the worst case, it would be n into n, or in every case we can say, because in every case we're gonna check for its extreme right and to its extreme left. Okay, and n is here the size of array or the size of string, what we can say. Okay, we can easily compute it out, but this is not a optimized approach, so we'll move forward to the most optimized approach. Now, one thing I am sure of is for every index I need to do a computation for the left elements or left boxes and for right boxes. Now, if we do some pre-computation so that for every index we can just perform some minute computation, or what we can say, we don't need to perform a computation for the particular index. We can do some pre-computation, and whenever there is a term of pre-computation, I look for a prefix array. Ki I can use a array that in which I can store the result for a particular index. Okay. Now, because here we are given the string, let's consider 0 0 1 0 1 1. Okay. So for each we require a computation towards its left, computation towards its right. So we will be requiring two arrays, prefix and suffix. Okay, that would be of the same size as the number of boxes that are specified to us. So 0 1 2 3 4 and 5. 0 1 2 3 4 and 5. The suffix would also be 0 0 1 2 3 4 and 5. Now, for each index in the suffix and prefix, I would calculate the what we can say, the total operations for this index that will be requiring. So the prefix would be containing total number of operations to make all the balls in the left to move to the particular box, and the right would be containing total number of operations that we will be requiring to move all the balls from the right to a particular index. Okay, it would be crystal clear कि a index, that is if we consider the 0th index, would be containing all the operations that would be requiring to move all the balls from the left of it to this particular box. Okay, so let's start. It would be more than clear when we do this, but when we perform this particular algorithm. If I'm at zeroth index, if I'm at the zeroth index, I don't have any element or any box on its left, so it would be 0. Okay. Now I make I will maintain a variable so that I would have the count of 1, and that would be helpful to us. Okay. We move to the next. Now the current count of 1 is 0 currently. I move to 1. I look for 1. I don't have any 1. Okay. It would be 0. I am at this 2. Now for this 2, I require the element on the left. I don't have any element. Okay. 0. But here I have increased our ones count by 1 because I have found a 1. That would be helpful for the next element when we are calculating for it. Okay. Then we look for this 3. Is there any element on the left? Yeah, there is a ball containing at the box 2. Okay. But how can I found it? So for 3, I can say कि the number of count, this prefix of 3 would be prefix of 2 plus the number of ones count. And why so? Because if we are moving कि if we are moving from 2 to 1, let's suppose till 2 we will be having 3 balls. Okay. And the number of operations would be what we can say 6. If the number of operations at the index, let me explain it with another example. It would be more than clear. Then we would take example of 1 1 1 1 1. Okay. I would be having my prefix, I would be having my suffix. Okay. We will continue that particular example once we are done with this. 1 2 3 4 0 1 2 3 4. Okay. 0 1 2 3 and 4. It would be more than easy for this example. Okay. So for 0, first element, none of the elements are 0, but the ones count would be increased to 1 when we are moving to index 1. If we are at index 1, the number of elements to its left are 1. Okay. And the distance for the previous box to reach them is 0. That means it would be this particular element. So we would set the value of the current index based upon the previous prefix value plus the ones count. Okay. I'll move to 2. I'll move to 2. Now the number of ones here are 2. So before moving to the 2th index, this one count would be increased. I'm at 2. Then I look for key the prefix of the previous element is 1. Okay. So but the number of counts are 2. So the value of this would be 1 plus 2, that is 3. If we check it, key to reach from 0 to 2, it would be 2. From reach from 1 to 2, it would be 1. So 1 plus 2, yeah, it would give me 3. Good. If we are at 3rd index, we have our value of prefix of this particular index 3 plus the number of ones count would now be increased to 3, because before moving to 3 I would have increment this 3 plus 3, it would give me 6. Now how come we have 6? So from move to 0 to 3, it would be 3. 1 to 3, it would be 2. 2 to 3, it would be 1. So 1 plus 2 plus 3 would give me 6. Okay. If I'm at 4, Now the number of, before moving to 4, I have incremented the ones count by 4. I have 4 elements to its left. Now the fourth index would be updated by 6 plus 4. How so? 0 from move to 0 to 4 would be 4. Move to 1 to 3 would be 3. Move to 2 to 4 would be 2, plus 3 to 4 would be 1. So 7 plus 3 would be 10. So basically what we are doing, we know at every step, if we know ki at every step we need to increment the distance by 1 when we are moving from the left to right, and if there are n nodes, we need to increase the distance by n. Okay, n ones, what we can say. Okay, plus the distance to the previous index. Okay, now similarly for suffix, for the particular index, we look for ones on its right. We for this we don't be having anyone. We look for ones count, it would be 1 for 4. Now we move to 3. Okay, we move to 3. For 3 we look for ones count. We first maintain a particular statement so that it would be easy for us, plus ones count. The similar thing which we are doing for the prefix. So the prefix of suffix of I would be updated by suffix of I plus 1, so that we would be having the distance to the next element plus the ones count, so that we can do the shift for this. So for 3, the number of elements are 1. The distance of the to reach them for the previous is 0. So 1 plus 0 would give me 1. Okay, I move to the next. Before moving to the next, I increase ones count by 1. It would be 2. Now for 2, it would be updated by suffix of I plus 1. 1 plus 2, it would be 3. How come? To reach from 4 to 2, it would be 2. From reach from 3 to 2 would be 1. Okay, before moving to the next, I'll increment the ones count by 1. It would be 3. Okay, now I am at this 1. Now it would be updated by 3 plus 3, 6. Okay, because the value of to reach the ones for the previous are 3, plus ones count would be 3. Before moving to the next, I'll increment the ones count. It would be 4. If I'm here, I look for key, the previous suffix is 6 plus ones count are 4. The value would be updated by 10. So if I have the minimum number of operations to move for the left part and minimum operations for the right part, we can add them and we can have our answer. So we would be having 10, 7, 6, 7 and 10 as our answer. Okay, for this particular test case, which we have left, boxes is equals to 0, 0, 1, 0, 1, 1. Okay, I would be having my prefix array 0, 1, 2, 3, 4 and 5. This would be my prefix. First element would be 0 and the count of this is ones count would be 0. We would be having our suffix. We would do its computation after we are done with prefix. Okay, so for this it would be 0. We move to the next. So the prefix of I would be updated by prefix of I minus 1 plus ones count. Okay, so for 1, if I'm at 1, prefix of previous 0 plus 0, it would be 0. Move to the next, it is 1. Once for the previous prefix element, it would be 0 plus 1's count would be 0. So it would be 0. Move to the next. Before moving to the next, the 1's count would be updated by 1. Okay. I'm at 0. The prefix of 0 would be 0 plus 1. It would give me 1. As we can see, to move from index 3 to 2, it will be requiring one operation. Okay. Now we move to the next. We are at 4. Before moving to the next, is it 1? No. I'm at 4. I look for the previous prefix value would be 1 plus the 1's count is 1. It would give me 2. Okay. I move to the next. Before moving to the next, the 1's count would be updated by 2. Now I'm at 5. I look for the prefix value of previous element 2 plus 1's count 2. It would give me 4. Nice. Nice. And if I move further, we don't have any further boxes, so it would be done. Now we look for suffix. 1's count initially would be 0. If I'm at 5th index, the 1's count would be 0. It would be 0 basically. If I move to 4, before moving to 4, the 1's count would be updated by 1. Okay. I look for the suffix. The suffix for index I would be updated by its next value, suffix of I plus 1 plus 1's count, current 1's count. So suffix of 4 would be suffix of 5 plus 1's count. 1's count is 1. So 0 plus 1 would be 1. I move to 3. Before I moving to 3, I increase the 1's count by 1. I am at index 3. I look for the previous, that would be 1 plus the 1's count, that is 2. So it would be 3. Good. Before moving to the next, we don't need to update because it is 0. I move to 2th index. Okay, it would be updated by 3 plus the 1's count 2. It would be updated by 5. Good. Before moving to the next, update the 1's count. I am at 1. Previous 5 plus 3 would give me 8. Okay, good. Now if this is giving me 8, then good. Before moving to the next, move to the before moving to the next, update this. We don't have 1 here. I move to 0. 8 plus 3 would give me 11. Before moving to the next, update this 1's count. It would be 3 because it is not 0. So I have the minimum number of operations for the left and for the right. If we try to find our answer, it would be prefix of I plus suffix of I, 11, 8, 5, 3, sorry, 3 plus 1, 4, 3 and 4. So 11, 8, 5, 4, 3, 4. Yeah, correct. So what's the basic algorithm, or what we can say, what we are thinking of? Ki if I am at a particular index I, है ना? If I'm at a particular index I and to its left, let's suppose I have a box. Let's understand it in terms of box. If I'm at a box I and if I'm at a box I minus 1, so for box I minus 1, we would be having the number of operations for this box, and if we are considering it as prefix, and for this I minus 1, we would be having total number of operations to move all the balls on the left to this particular element. And if we have all the number of balls to move from all the balls on the left to move, let's suppose it would be x. Now if this would be 1, then of course each of these balls would be requiring let's suppose we have three balls. So the distance would be can be 1, 2, and 3 till box I minus 1. If we are moving to box I, these all distance would be increased by 1. Okay, because we are moving 1 to its left, it would be 2, it would be 3, it would be 4. Okay, and if this ball is also 1, then the number of ones for this is also added. So that's why we are just adding x plus n. Ki if this is, let's suppose, 6 plus 4, the number of ones, that would give me 10. So in this case it also would give me 10. 3 plus 4 plus 2 plus 1 would give me 10. Similarly, this was our thinking for the right. Okay, and if we try to look at its code, it is quite simple. I just show you the code because I will not be coding it out. Okay, let's move it to our code editor. Okay, let's format the code. Okay, easy. We would be having two prefix and suffix array of the same size. Okay, I can do a thing. Key, I could move this in my notes so that I can easily make you understand this problem. Give me a second. Okay. Let's see. As discussed, we would be having a prefix, a suffix array of the same size. The prefix of 0, that is the leftmost element, would be having 0 number of operations to move all the balls to its left to this particular index. Similarly, the rightmost element, that is for the suffix, we would be requiring 0 number of operations to move all the balls towards its right to this particular index. Okay, so we would be starting a loop from the 1th index for prefix, because for the prefix of 0 it would be basically 0, and but we are checking the ones count for the index at 0 so that it would be helpful for our 1th index. For each particular index we would be doing the same thing. Key prefix of I would be updated by prefix of I minus 1 plus the current ones count, and if we are moving to the next element, before moving to our next element, we would be checking if the current element is 1, increment ones count by 1. Similarly, when we are doing for suffix, so here the prefix work is done. For the suffix, the rightmost element, we have already specified ki the number of operations for this would be 0, but we would check for its ki it will contain a box or not, a ball or not. So the box, last box, we'll check if it has a ball, then increment our ones count by 1. Sorry, increment not, initialize our ones count by 1. Then we start our loop from the second last element, and the same thing we would be doing for the suffix of 1 would be updated by suffix of I minus 1 plus the ones count. Before moving to the next element, that is basically in this case the previous element, we would be updating our ones count. So when the suffix is done, we have the number of operations for the left, number of operations for the right. We would be adding this value and updating our answer. Okay, so the time complexity of this would be 3n. One loop, one loop, one loop, three loops, 3n, that is approximately order of n. And the space complexity for this would be order of 2n, because this particular answer array would not be considered in our algorithm because it is just to return our answer. So it is also order of n. Okay, so we have optimized our solution. So this was the solution to the problem minimum operations to move all the balls to a particular box. If you have any doubt, you can ask in the comment section. and for more further videos you can subscribe to the channel. Okay, bye bye.